This is a typical dynamic programming problem where we want to maximize our profit by making as many stock transactions as we like. There is no limitation. Each time we sell a stock, we subtract the transaction fee from our profit. However, we cannot hold more than one stock at a time. So we need to sell our current stock before we buying a new one. And it's needless to say, we must have a stock before we can sell it. So let's use a drawing to help explain it better. Let's imagine ourselves in the market today and consider two options. Either we currently own a stock or we don't. First, let's examine the case where we have a stock. If we have a stock in ith day, let's call it true. This is the maximum of two things. There are two possibilities leading up to this scenario. Either we had a stock before that day and we were essentially inactive, or we didn't have a stock and we bought it today. Since we bought it today, minus sign. This is the equation 1. Next, let's examine the case where we don't have a stock. If we don't have a stock, again, there are two possibilities. Either we didn't have a stock before that day and we were inactive, or we had a stock and we sold it today. Since we sold it, that's why the plus sign. And since we finish a transaction, we have to decrease the fee amount. Now, let's translate this algorithm in the code. Let's take the length of the prices array. If there are less than 2 days available, it means that even if we buy a stock, we won't be able to sell it. So in this case, we simply return 0 as the maximum profit. To represent the two possible states, which are having a stock or not, and track the maximum profit, we need a two-dimensional array. We will iterate through the prices array and implement the equations we discussed earlier, but using 0 to represent not having a stock and 1 to represent having a stock, since we cannot store booleans in an integer array. So let's create our array. And let's iterate. We will leave it empty now. If we have a stock, that means we had a stock before that day and we were inactive, or we had no stock and we bought it today. The other option is if we have no stock, that means we had no stock before that day, or we had a stock and we sold it that day. So we have to decrease the fee amount too. So since we go back 1 day, we will start iterating from index 1. Now let's set the base cases. Initially, in first day, not having a stock is represented by 0, and having a stock in first day means we bought it in first day. There is no any option, so let's write them. Actually, we don't write this one because it's already 0 by default when you create an array in Java. But let's keep it that way to make it more readable. Now, what should we return? If we reach the end of the array while still having a stock, it doesn't make any sense because we haven't sold it yet. So we should return the option of not having a stock. Now let's discuss the time and space complexity. Since we iterate through the prices array just once, the time complexity is going to be O(n), and since we used a two-dimensional array of size n times 2, space complexity is going to be also O(n), since the coefficients do not include it in space or time complexity. So let's write them. So now let's check the performance on Leetcode. As you see, both of them are quite poor. So let's look at how we could improve our code. To improve the performance of our code, we can utilize two variables instead of an entire array called DP. Since we only need the data from the previous day, as you can see here, to calculate the future options, there is no need to store the oldest data. For instance, let's say we are in the fifth day, we only need the fourth day information. We don't need the second day or first day's information. So we can initialize these variables similarly to how we did when we're using an array. We can define two variables named have stock and no stock, and then we will iterate through the prices array, updating the have stock and no stock variables based on the equations we discussed earlier. So let's delete all of this and initialize our variable. Having a stock in the first day means, and having a no stock in first day means 0, and we will iterate. Now, if we have a stock, that means we may had a stock before that day, or we had no stock and we bought it today. If we have no stock, that means we had no stock before that day and we were inactive, or we had a stock and we sold it today and we have to decrease the fee amount. And at the end, we will return the no stock option because we don't want to waste money. So now let's check the time complexity and space complexity. But also we need to care about this having a stock option doesn't represent the previous day because we updated it here. So we need the previous day's have stock option. So let's store it in a temp integer and write it here. And now let's check the time and space complexity. Time complexity is going to be O(n) again. And the space complexity is improved to constant because we didn't use any additional data structure or array. So let's check the performance on Leetcode. As you see, they both quite improved. I hope it has been helpful to you. Thank you for watching.